What if Antarctica melted instantly? All of it, right now? What if 26.5 million cubic kilometers of ice, a number so large it has effectively stopped meaning anything, liquefied not over centuries, not over decades, but in a single moment? Antarctica is a continent roughly twice the size of Australia, buried under ice that averages 2.1 kilometers thick. That's not a glacier. That's a geological event frozen in place. It is, by any reasonable measure, one of the most violent stores of potential energy on the surface of this planet. This isn't your standard slow-motion climate video. We're not here to talk about what happens by 2100. We are here to explore what happens immediately in the physics, the biology, and the geopolitics if the white sheet gets pulled off the bottom of the world in one go. And here's the thing nobody tells you up front. The water doesn't just rise. In some places, it runs away from Antarctica entirely. Stay with me. So what if the ice is gone? Let's start with the number. 58 meters. That is how much global sea levels would rise if every last gram of Antarctic ice melted into the ocean. 190 feet. For reference, that is roughly the height of a 19-story building, now underwater, and that building used to be your city. What if you lived in Florida? It's gone. Not mostly, not partly, gone. The Netherlands, which has spent centuries engineering itself above sea level, through sheer Dutch determination, ceases to exist as a contiguous landmass. Denmark loses most of its territory. Bangladesh, home to over 170 million people, essentially disappears. The Amazon basin becomes an inland sea. Entire island nations in the Pacific, which were already watching the water creep toward their doorsteps, are simply not there anymore. Shanghai, Mumbai, New York, Tokyo, Houston, all of them underwater. The combined economic output of those cities represents trillions of dollars of infrastructure, built over centuries, now serving as an artificial reef. And the kinetic reality of an instant melt is not just more water in the ocean. It is a catastrophic displacement event. The Southern Ocean receives a volume of fresh water so massive, so instantaneously, that it radiates outward with the force of a global-scale hydraulic shock. Waves, surges, a reorganization of ocean surface dynamics that would be visible from space. If you live in a coastal city, your ocean view has just become an ocean living room. If you live in Denver, congratulations, you're now beachfront property. But what if drowning cities were only the beginning? The real story isn't even what the water does, it's what it doesn't do, and where it goes instead. Here is something that will break your intuition, and it is 100% established physics. The Antarctic ice sheet, all 2.6 times 10 to the power of 19 kilograms of it, has its own gravitational field. That is not a metaphor. That is not a simplification. A mass that large physically pulls the surrounding ocean toward it, like a slow geological tide that never goes out. Right now, as you watch this, the Southern Ocean sits measurably higher near Antarctica than it would if the ice weren't there. The ice sheet warps the water. So what if that gravitational anchor simply disappeared? The ocean relaxes. It slouches away from the South Pole. The gravitational signal that held the Southern Ocean in place vanishes, and water redistributes outward, northward, toward the equator and the far northern hemisphere. While New York and Shanghai are drowning under 60 meters of water, sea level within several hundred kilometers of Antarctica would actually drop. The birthplace of the flood is one of the few places on Earth that doesn't drown in it. Scientists call this sea level fingerprinting. Every melting ice sheet has one, a unique global pattern of where water rises most and where it falls. Antarctica's fingerprint is particularly dramatic because its mass is so concentrated at the bottom of the world. When it lets go, the water doesn't just spread evenly like a bathtub overflowing. It cartwheels across the planet, rising fastest in the tropics and the mid-latitudes, exactly where the most people live. It's the ultimate cosmic irony. In this what-if scenario, the driest place on Earth would be the one place the water came from. But what if the flooding isn't even our biggest problem? Because something far older than civilization is about to wake up. Antarctica has been frozen for approximately 34 million years. In that time, it has functioned not just as an ice sheet, but as the world's largest biological time capsule. Permafrost, frozen soil that never thaws, is one of the most effective preservation media in nature. Cold, airless, dark. It is, biologically speaking, a pause button. And we have extensive evidence that the things inside it can simply unpause when the temperature changes. In 2005, NASA scientists revived Carnobacterium pleistocenium, a bacterium that had been locked in Alaskan permafrost for 32,000 years. The moment the ice melted, it started swimming. Not it showed some chemical activity. Not traces of DNA were detected. It swam. First validly described living organism recovered from ancient ice, active after 36 millennia. Separately from deep ice cores drilled at Antarctica's own Lake Vostok, living bacteria have been recovered from ice that formed millions of years ago. The ice is not sterile. It never was. In Siberian permafrost, researchers have revived giant viruses, pithovirus for instance, frozen for 30,000 years, and found them capable of infecting cells upon thawing. These are not theoretical threats cataloged in a database. They are functional biological entities that have simply been waiting. And here is where it gets clinically interesting. Our immune systems develop their defenses through exposure, through evolutionary time spent alongside pathogens. Ancient microorganisms that have been sealed in ice since before Homo sapiens existed have had no contact with our modern immune landscape, and we have had no contact with theirs. The encounter, if it occurred at scale, would be immunologically novel on both sides. Ancient permafrost bacteria have also been found to carry genes conferring resistance to modern antibiotics, resistance that evolved long before antibiotics were invented, through entirely different biological pressures. So what if we released pathogens we don't just fail to recognize, but pathogens we can't treat? We have spent decades building out global pathogen surveillance infrastructure, and an instant melt wouldn't just test it. It would release biological diversity faster than any surveillance system in history could characterize. We've spent centuries perfecting our medical toolkit only for organisms that last saw sunlight during the Miocene to show up and say, "Hold my beer." But what if the ice isn't just holding biology? What if it's also holding geography? Pull back the ice, and Antarctica stops being a featureless white dome and becomes one of the most dramatic landscapes on Earth. Beneath the central plateau of East Antarctica lies the Gamburtsev mountain range, a subglacial chain roughly 1,200 kilometers long, with peaks reaching approximately 2,700 meters above the underlying bedrock. Scientists who have mapped it using ice-penetrating radar describe it as remarkably similar in scale and character to the European Alps. Sharp ridges, deep valleys, glacially carved architecture, except that no human has ever stood on a single one of its summits because they are buried under up to 4 kilometers of ice. The Gamburtsevs have been there for hundreds of millions of years, and we discovered them in 1958 by accident, when a Soviet expedition detonated test explosions to measure ice thickness and found, inexplicably, that the ice was thin. There were mountains underneath. Then, there is the canyon system beneath Princess Elizabeth Land in East Antarctica, a network of subglacial canyons stretching for over 1,100 kilometers, longer than the Grand Canyon, and in places more than a kilometer deep, mapped not by boots on the ground, but by satellite imagery and airborne radar, because no one has ever been there. It is, in terms of unexplored terrain, one of the last blank spaces on Earth's surface. And then, Lake Vostok, a subglacial lake roughly the length of Lake Ontario, sealed beneath nearly 4 kilometers of ice, isolated from the atmosphere for an estimated 15 million years. Its waters may contain life forms, adapted to conditions that no longer exist anywhere else on Earth's surface. What if exposing it meant releasing the largest sealed ancient ecosystem in recorded history, all at once, and the continent itself would begin to move? Without the full weight of the ice sheet pressing down on it, the bedrock would start to rise, a process called isostatic adjustment, or glacial rebound. It is the same process happening right now in Scandinavia, which is still bouncing upward from the end of the last ice age 10,000 years ago. Antarctica, relieved of a weight several orders of magnitude larger, would eventually rise by hundreds of meters, not in hours, but over thousands of years of geological readjustment, a new continent in every meaningful sense, and a planet that would soon begin heating itself. Ice is white. It reflects approximately 80% of the solar energy that hits it back into space. Open ocean is dark. It absorbs approximately 94% of the solar energy that hits it. In climate science, this property is called albedo, and it is one of the primary reasons Antarctica currently acts as a thermostat for the planet. What if you remove that thermostat entirely? You have replaced one of the most reflective surfaces on Earth with one of the most absorptive. The Southern Ocean goes from mirror to heat sink. Global temperatures, already destabilized by the melt, receive a sustained, self-amplifying push upward. The thermostat becomes a heater, and it doesn't come with an off switch. The warming accelerates through a second mechanism. Beneath the ice and throughout the permafrost zones of the subpolar regions lies an enormous reservoir of ancient organic matter, dead plants, animals, and microbes that never decomposed because they were frozen solid. As the temperature rises and this material thaws, microbial activity resumes. The organisms eat, and in eating, they release methane and carbon dioxide back into the atmosphere at a rate that, in a full collapse scenario, would dwarf current human industrial emissions. Methane is, over a 20-year horizon, more than 80 times more potent as a greenhouse gas than carbon dioxide. A large-scale permafrost thaw is not a secondary effect of warming. It is a multiplier, a feedback loop that accelerates the very process driving it. And then there is the ocean circulation problem. The Atlantic Meridional Overturning Circulation, or AMOC, is the planetary scale system of ocean currents that distributes heat across the globe. It runs on density differences between warm, salty surface water and cold, dense, deep water. The Gulf Stream is part of it. It is, effectively, Europe's central heating system. What if that heating system shut down? An instant flood of Antarctic freshwater into the global ocean dramatically reduces the salinity and therefore the density of the water that drives AMOC. The conveyor slows, possibly stops. Paradoxically, while the rest of the planet bakes, northwestern Europe could experience a rapid cooling as the warm water that keeps its climate temperate ceases to arrive. One world getting hotter, one region getting colder. Both consequences of the same event. Now let's talk about 3.5 billion people, the approximate number currently living within striking distance of a 58-meter sea level rise, suddenly needing somewhere else to be. What if the geopolitical map had to be redrawn from scratch? The coastal megacities, the economic engines of the modern world, are gone. The nations that survive largely intact are those with elevation. Russia, with its vast interior, Canada, suddenly warm enough to farm its northern territories, parts of Central Asia and sub-Saharan Africa. The high plateaus of South America and East Africa become population centers overnight. And then there's the strangest what-if of all, Antarctica itself. It has been frozen for 34 million years. But before that, during the Eocene, it was a temperate continent. Evidence from fossil pollen and leaf impressions shows that it once supported forests, including species related to palms. A post-melt Antarctica, freed of its ice, sitting at the bottom of a warming planet, receiving newly intense southern sunlight onto dark, rich bedrock soil, would, over centuries, begin to green. This is not speculation about the far future. It is simply the planet returning to a configuration it has occupied before. The factory settings, reset. The new frontier, fought over, claimed, colonized, and contested, just as every other temperate landmass in history has been. So here's what our what-if actually looks like. 58 meters of sea level rise, distributed unevenly across the globe, rising fastest in the tropics and mid-latitudes, and, impossibly, falling near Antarctica itself. Ancient biology, sealed for tens of millions of years, releasing into an ecosystem entirely unprepared for it. A continental mountain range and a canyon system longer than the Grand Canyon, finally visible after being locked under ice since before humans walked the Earth. A climate feedback loop with no natural ceiling, 3.5 billion people in motion, and a new continent slowly emerging at the bottom of the world. We don't live on Earth in some stable, permanent sense. We live on a very specific, very delicate arrangement of frozen conditions, ice sheets, ocean circulation patterns, atmospheric chemistry, that happen right now in this particular geological moment to support everything we've ever built. The ice isn't just scenery, it is infrastructure, the oldest and most critical infrastructure on the planet. And unlike a bridge or a power grid, there is no engineering team standing by to fix it. What if you had to start over, pack one bag, and move to the new tropical Antarctica? What's in it? Let us know below. And if you want to keep exploring the what-ifs that the textbooks don't cover, you know where the subscribe button is.